All right, now we're going to do different shaped matrices. And let me show you how you know that. So let's say you had something that was 3 by 2. Okay, now remember, a 3 by 2 matrix has 3 rows and 2 columns. Okay, so that's going to be shaped kind of like 1, 2, 3, 4, 5, 6. And just for the sake of showing you how to do this, I'm going to stick with just positive numbers. And let's say I'm going to multiply this by a matrix that was 2 by 1. Okay, now a 2 by 1 matrix is kind of long and skinny. So it's kind of like that. And let's say we have the numbers 3 and 4 in there. Okay, now first question, can you multiply this? Absolutely can, because the inner dimensions match. That's the whole point of that. How big is the answer matrix going to be? That is going to be the outer dimensions. Right, 3 by 1. So my answer matrix is 3 by 1. And I think a mistake that people have made that I've seen for 20 years now is that they don't start with the picture over here. This is not only 3 by 1, but it's going to be long and skinny like this. And it's going to have 1, 2, 3 answers on there, just like that. Okay, so we have to fill in these numbers. And it's always row times column. No matter what you do, it's this row times this column. All right, so let's do that. So it's 1 times 3, which is 3, plus 2 times 4, which is 8. And that winds up being 11. If you're a little bit behind or you didn't catch that, go back and watch how I move that marker around there a little bit. On the next one, to get this one here, that's going to be 3 times 3, which is 9, plus, always plus there, 4 times 4, which is 16. That's 25. Then to do this last one, I'll slow it down here a little bit. You get this row times this column. Okay, row times column. So that's going to be 5 times 3, which is 15, plus 6 times 4. This row times this column. 6 times 4 is 24, so that winds up being 39. Okay, so there's a great example of taking two different dimensions and getting another weird shaped thing. If you're wondering, by the way, let's settle this rumor right now, is multiplying commutative? Commutative. Well, let me prove to you that it is in fact not, because if I say 1, 2, 3, 4, 5, 6 times 3, 4, this is a 3 by 2 and a 2 by 1. You can multiply that. But if I invert these and take a 3 and a 4 times this other matrix, 1, 2, 3, 4, 5, 6, this is now a 2 by 1 and a 3 by 2. Can I multiply that? No, you can't multiply that because the inner dimensions don't match. This here actually has no solution. Okay, no solution on that. This one has a solution. So they're no. That's a no right there. That's a no. Sometimes on square matrices, like the 1, 2, 3, 4 type 2 by 2s and a 2 by 2, you can flip-flop those. Sometimes, and sometimes you can't. So I recommend just doing it over if you have to. So let's do one other little example here before I quit, since I have you. Okay, real fast. We're going to define two matrices, 1, 2, 3, 4, and B. I just want to show you a concept here of 2, 4, 6, 8. And let's say I wanted to do two examples here. Example 1, 3A. And I want to know what 3A equals. Well, you might be thinking, can I just take 3 times each of the entries in that matrix? And you would be correct. That's exactly what you do. So if you ever have to do like 3A or 3 times a matrix, it's just going to be 3, 6, 9, 12. Final answer right there. That's how you would do something like that. Now, example 2, I want to show you, this would be example 1. In example 2, I want to show you what may look painful at first that actually isn't. Let's say we had one that was like 6b minus 2a minus 5b plus 2a. And if I said, have fun today, I'll see you tomorrow, and you had to do that, this would be terrible. Terrible, I tell you. The question is, can I simplify this? And the answer is yes. And it would be foolish not to. So look at it. You have 6b minus 5b. What's that? That's 1b. And then I have negative 2a plus 2a. That cancels. So this whole mess here simplifies to just b. So what's b equal? Well, 2, 4, 6, 8. So I can get away by doing a problem like that without doing any math, because this is legal right here. This is okay to do. This is simplifying. You guys have a good one.